Hello, everybody, and welcome to Intro to Dental 3D Printing with Dr. Nitish Surathu. If that video didn't get you out of bed and wake you up and get you moving and excited about 3D printing, I don't know what will. No matter what time zone you're in, that music, no matter what time of day it is, that music just seems to get everybody fired up. My name is Tom Caulfield, General Manager of the Americas at Ackuretta, and I'll be your host today. But more importantly, I have the pleasure today of introducing our special guest speaker for today's lecture. It's Dr. Nitish Surathu, and you're going to hear so much from him in just a few short minutes. Whether you're 3D printing now or just interested in learning more about 3D printing, wait to see his presentation, what's coming up. He's calling in from India today, but he's been practicing in New Zealand for the past several decades. As a periodontist, Dr. Surathu is also an accredited associate fellow of the American Academy of Implant Dentistry and a fellow and diplomat of the International Congress of Oral Implantologists. He's lectured around the world on periodontics and dental implants in countries to be actively involved with podium lectures, hands-on, and clinical courses. In fact, later this year in March and April, or later next year in March and April, he'll be lecturing in Australia, New Zealand, and the United States. Dr. Surathu is further served on the Executive Council of the Asian Pacific Society of Periodontology and for over a decade, and is currently director at the ACE Institute. His expertise really lies in all digital matters. He's actively involved with the evaluation of new generation digital technologies in intraoral scanning, CAD/CAM software, CAD/CAM milling, 3D printing, guided implant surgery, and relevant materials. It's fair to say that Dr. Surathu may be one of the most knowledgeable speakers we could have asked for, and we're thrilled to say that he's been using the Ackuretta system for the past 2 years. Dr. Surathu, we really appreciate you being here, sharing your knowledge, taking the time. I know it's a little late in India right now, but there is quite a few people here in the U.S. just waiting to hear from you. And before we give you the microphone to take over and educate all of us, I'd just like to give everybody a brief outline of today's lecture. Today, Dr. Surathu will give us an in-depth overview of why 3D printing is becoming increasingly popular for clinicians as well as technicians. He'll give us a quick introduction to the main uses of his own equipment and what he produces most often with his 3D printer. He'll touch upon scanning, design, and outsourcing of CAD design, and provide us with a quick overview of why the Ackuretta system is his go-to printing. Finally, Dr. Surathu will give us particularly important and necessary introduction to patient safety protocol, what we call validated printing workflows. And then we'll finish with a live Q&A. You'll be able to enter your questions into the little questions tab on your bottom right-hand screen, and then we'll read off the questions. And again, if it'll be a live Q&A, so if you're thinking of it, please don't hesitate to put your questions in when you're thinking of it, because I'm sure somebody else on this webinar will be thinking of it as well. Again, thanks so much for taking the time today. We hope that music got you all fired up and excited to learn about Ackuretta and 3D printing with Dr. Surathu. And thank you, Dr. Surathu, for taking the time to make this happen. And now I'm going to hand it over to you.
Thanks, Tom. Can you hear me?
We can hear you fine, Dr. Surathu.
Wonderful. Can you see my first slide?
Absolutely.
Wonderful. Right. I want to thank everybody who's logged in. Thank you for taking the time. I know you have a choice of online education in today's post-pandemic world, and I'm grateful to have you listen in on this one. It's about 10:30 in the night where I am at the moment. I live between pretty much two continents, and I find myself in the wrong one at this time as far as time zones go, but that's all right. Let's get on with it. The lecture itself is meant to be an introduction to 3D printing, and so I'm going to try and keep it basic. I'm going to try and keep it something that caters to a relatively larger denominator. And we'll see. Hopefully there's something for everyone in the presentation. We intend to up the ante on these presentations and gradually get into more advanced 3D printing, but the scope of this lecture at least is an introduction to 3D printing, and I'm going to keep it limited to just that. I've been 3D printing for a while now. I bought my first 3D printer about 5 years ago. I remember being in a meeting in Las Vegas, I think it was. And I bought a Moonray, which was then made by the Sprint Ray company. And it was my first 3D printer. I was excited by the technology. I did 3D print quite a bit. I can't say that it wasn't without its pitfalls, but we've come a long way since then as an industry, and in terms of the products that we have available today on the market, printing is just super easy today. And for most people, using the word printing brings up you think of a regular printer, right? A paper printer, and you feed paper into it, and you've got inkjets, and then they put out a sheet of paper with text on it or whatever. This is quite different. 3D printing itself is quite different, and the technology itself is quite different. Although we do have similar jet printers, which perhaps is not something we want to talk about here. But let's move on to understand what printing is about today. Why 3D print at all? And this is a question I get often. I get practitioners who ask me, is it the right time to get into 3D printing? Should I be getting a 3D printer for my office at all? Is it worth doing? And people have a lot of questions about what they can produce with 3D printing in the first place. So I think I'll start with that and tell you a little bit about what I do with 3D printers in my office. I print with multiple printers. The Sol is certainly one of my favorite printers, and I have a Sol pretty much in every location that I do anything. And I use it for a lot of things. And so you can print models, surgical guides, temporary crowns, definitive crowns, immediate dentures, even definitive dentures, denture teeth, bonding trays for orthodontic appliances, special trays for impressions for implants and teeth, gingival masks, if you like that kind of thing. Night guards, I do a lot of those. Splints, again, do a lot of those. And implant prosthetics, even full arch implant prosthetics. You'll notice I left out castable patterns and castable crowns. That's not something I've ever done, but certainly that's a laboratory application. Those castable resins burn out completely, allowing somebody to cast in gold or whatever metal they're looking to cast in. But I've certainly done everything else, and that's a wide range of applications if you needed a reason to get into 3D printing at all. I'll go through some of the more common things I do with my 3D printer very quickly. Models are certainly right on top. These are all unusual models, if you'll allow me to say so. If you look very carefully on the upper right, at the upper right picture, you'll realize we've created bleaching bubbles, and really these are models on which we thermoform bleaching trays. In the old days, we used to put in LC blockout resin and then create a little bubble for ourselves on these teeth. But it's so easy to do that today with CAD design, and then print these models out and then thermoform a bleaching tray. There's a couple of models there that are regular study models as well. On the upper left, you see what's called a Geller model or a crown and bridge model or a die model. I do those quite often. That particular case involved removal of a large number of PFM restorations, which is why you see extensive preps. I didn't prep those teeth. I tried very hard to conserve what I had left of those teeth, actually. But that kind of printing allows me to print dies. That's very, very easy to do. And I use those models often to check contacts, to check the fit of my veneers and that kind of thing. On the lower left corner, you see a model with an odd-looking pin projecting in front of it. That's an articulation pin, and I do create for myself articulated models sometimes. And so there's a large number of types of models that you can print for yourself, and model printing is certainly right up there in terms of what people use their printers for. I use my 3D printer as well to provide, or rather to print temporary and definitive implant restorations. On some of my slides, I've got this logo that you see on the left, an application with increasing 3D printing use, because this is growing for me as an application, because we've got new resins that are fantastic for implant restorations. They're essentially hybrid resins, if you like, hybrid between ceramic and resin. And they've got very favorable wear characteristics, and that works very well for me on implant restoration. So that's a growing usage of my printer in terms of an application. This isn't my picture, but it illustrates an implant special tray, one that you can design quite easily using CAD software to take open tray implant impressions. And I do this very, very often with my printer as well, because it's so easy to design these on CAD software and print them rather than make holes in special trays or get a lab to make you one, or make holes even in stock trays. I see people who do that as well. So this again is an application with increasing 3D printing use for me. Surgical guides. If there's one application for 3D printing that I've used from the beginning, it's got to be this one. Surgical guides are so much more economical to print than mill. In the early days, I used to mill my surgical guides. Nowadays, I pretty much print all of my surgical guides. It's so cost effective to do that. You may need to calibrate sometimes. depending on the resin you're using. And on the upper left corner, what you see is a calibration print. And then you're able to tell an implant planning software sometimes what kind of dimensional tolerance you want for your surgical guides. But these work so well, and those sleeves drop right in if you've got everything set up very nicely. And I love printing surgical guides, and this is easily one of my own personal most extensive uses for 3D printing. But this is growing massively in my own practice, whether in New Zealand or in India here, where I work as an associate. I work a lot with these 3D splints and Nightguards. For some strange reason, we're seeing a lot of people with wear that's bruxism related. And again, this is becoming an application with increasing use. I typically will do these with what's called a Brux checker. This is a thermoformed sheet that's available from CURIE Dental, the German company that makes Ministar and BioStar. And I like using this sheet because I like to assess whether the patient is an active bruxer at a given point in time, or whether I'm looking at something that is a past consequence of bruxism. And so when I use these Brux checkers, I give them to patients for a couple of days. They usually come back and show me what the Brux checker looks like. And on the lower right corner, you see a picture of what it looks like if there's actual bruxism. It wears through the ink in the sheet, and that's a very good indication of what you are dealing with. I then typically take intraoral scans for these patients, and I take them with a Lucia jig in place that hopefully deprograms them to some degree, and it gets me an occlusal relationship that I actually want to fabricate my splint in or fabricate my night guard in. I really love this with modern intraoral scanners because I used to take an impression, an upper and lower impression, and then we used to do a suck down night guard, and typically a lot of it needed occlusal adjustment in the patient's mouth when we delivered the actual appliance. Now with intraoral scanning and being able to scan open bites, so to speak, in the right position, we are able to actually fabricate splints and night guards that are the appropriate thickness for each patient. And I'll almost never need any kind of adjustment with some of these appliances, and they fit beautifully. And this is an absolutely growing indication for me for 3D printing. Here in India, when I work here in India, we also print orthodontic aligners. And we create these models on orthodontic planning software like Archform or Maestro 3D or whatever it is. Often we work with outsourced planners because it's not really my area of expertise to do orthodontic treatment planning, but you can outsource that, and then we get STLs of models that we can print so easily in office, and then we thermoform aligners on these models using Zendura, one of the most popular aligner and retainer materials that we use. We do use others, but this is by far the most effective material that I know of that you can use for orthodontic aligners. I also print dentures. I mean, I'm not somebody who especially loves dentures, or at least I didn't until I could 3D print them. But ever since I've gone digital with my dentures, I absolutely love designing dentures on software. I work with other technicians or my son who's a pros resident and get help with some difficult cases, but I'm able to design these quite well otherwise and 3D print them. We've printed these in a variety of materials, and I'm actually going to go out on a limb here and say printing is probably far more suited to dentures than even milling. The reason for that is something that is essentially underscored by a huge advantage that 3D printing offers. On the extreme left, you see a picture of the patient's denture, the one that he came in with, fairly worn down denture. We copied that denture and attempted to digitally recreate it. The pic in the center is a 3D printed denture, whereas the one on the extreme right is a milled denture. The nature of milling is such that milling will always take away the undercuts. That's just the nature of the technology itself. And when you have undercuts eliminated, because you're sort of limited by the shape of your burr and the axis at which the burr can actually impact a block of acrylic or PMMA, you really have a situation where a denture may not be a perfect fit if it's milled. That's not true of every case. We certainly mill dentures for some patients. But in cases where we have a fair degree of undercut, like in this case, I often find that printing does much better for us. And we've printed so many dentures. With immediate dentures, we almost 100% print. We mill sometimes for definitive dentures, but with immediate dentures, we're printing all the time. We do print teeth as well, especially for our immediate dentures. We do print teeth. Bear in mind, though, that when you print teeth, you don't quite get a gradation of shade. You get that with milled teeth. And so with definitive dentures, we sometimes mill teeth where you get better shades and better aesthetic outcomes. But we certainly print teeth all the time for immediate dentures because we see those as being dentures that are going to be in the patient's mouth for a limited period of time. And one of the things I like about printed teeth is you can print a whole arch form or you can segment these teeth for convenience. And we bond these teeth eventually to the denture base. So the denture base is printed in a separate resin, a pink resin, obviously, and the teeth are printed in another resin. This is a denture that has milled teeth. And you can see how we've beautified, if you like, the denture base using GC Gradia resin and a few other colors from GC's OptiGlaze system. You can make a denture look reasonably pretty by using some of these materials. Obviously, the material is totally polishable as well, and we do that as well. This was an LMT survey, really, to kind of figure out what it is that the dental industry is using 3D printing for. I'm not surprised to see models for crown and bridge on top of the list. I'm not surprised to see study models on top of the list. And labs probably account more for those numbers than dentists, really. But I'm quite surprised to see Nightguards and Splints right up there. And this is fairly recent data from last year. And as I said earlier in the presentation, we've been seeing an increased amount of bruxism and clenching in the last year. I really believe it's related to some degree to the pandemic and the kind of post-pandemic world that we live in today. But Nightguards and Splints are certainly amongst the top three most common applications for 3D printing today. We've got soft splints for Nightguards, which is one of the things that got me excited about the Sol when I first got it. I still print soft splints as well in it, and I do print hard splints as well, and we do print Nightguards as well in this material. So there's a good number of reasons to get into 3D printing, but let's talk about a couple of other reasons which are perhaps a bit left field. There's certainly literature out there that suggests that 3D printing is more accurate than milling at this point in time. This is partly related to what I said earlier about undercuts and the fact that milling tends to compensate undercuts by over-milling. That's called an offset mill, and offset milling is something anybody who's doing milling understands really well. 3D printing, on the other hand, will print to fit exactly with no compensation of the undercut whatsoever. So I'm not surprised to see that 3D printing is more accurate than milling. What I am surprised to see, though, is that the margins of these restorations also showed a better fit with 3D printing than they did with milling. So that's interesting, because a lot of dentists think that 3D printing is not as accurate as milling, and that the answer is actually, the reality is that it's actually not quite true to believe that. And so there is increased accuracy with 3D printing that we are starting to see in the literature as well. And this isn't the only study that's actually put out data of this nature. Interestingly, in this study, the 3D printing resin that was used for restorations was the Saramco Crown Tech resin, and you can use this on the sole. It's not made by Ackuretta, but it's one of those third-party materials that Ackuretta gives you access to, and it's really a beautiful material. There are many other materials that I'll talk about for crown printing in a moment, but the Saramco Crown Tech is certainly right up there. And so this particular resin showed fantastic fit. And in the study, it also showed excellent physical properties. The study actually suggested that crowns printed with this material were just as strong as milled restorations, if not better than milled restorations. So that's quite interesting. It's one thing to have accuracy of fit. It's another thing to find out that the physical properties of the material are just the same as other resin ceramic hybrids that can be milled that I've named on the slide. I do use a variety of other materials as well for definitive and temporary crowns. I do love the Bigo Wasio Smile Crown Plus material. You can buy this from Vipmix, and you can buy it from a couple of other companies in the United States. Great material, excellent flexural strength, and I do like this material as well, and it prints very well on the sole. Also like the PacDent rod in sculpture. I have never used this material. I should be laying my hands on it next week. I've heard great things from the US where it's FDA approved, of course. And one of the things that's unique about this material is it's probably only one of two resins on the planet that I'm aware of that are more than 50% filled. Starting January 1st, 2023, dentists in the United States will be able to code these as porcelain restorations, as ceramic restorations, and that's quite interesting. But this particular material is being used even for full arch implant prosthetics, and I can't wait to lay my hands on it next week and see what I can do with it. But PacDent's making some absolutely beautiful resins that are all compatible with the sole as well. So again, some great reasons there to 3D print, but let's look at some more. This is one of my biggest reasons why I think you should get into 3D printing. I see a lot of dentists stepping out into digital dentistry, and one of the first steps they take is to buy an intraoral scanner. But a large number of dentists stop right there as well, and I've never quite understood that. And so I asked dentists what kind of return on investment they expect from buying just an intraoral scanner. And I don't just get it, because it's going to take you a lot of impressions to make up the ROI on an intraoral scanner. Your lab's certainly going to be very happy with you because it digitizes the workflow. It makes it much more economical, much more efficient for the lab as a workflow when you go digital. But I don't know, I can't see how dentists benefit from it. Yes, they become more productive. Yes, they become more efficient. But if you added a milling machine or you added a printer to the digital workflow that flows from your intraoral scanner, you'd be able to immediately do so much more and just amplify that return on investment. A milling machine, of course, tends to be a fairly expensive proposition. And so I see 3D printing as a very practical, economical starting point in the implementation of a true digital workflow for most dentists. So think about that. I mean, 3D printers today, something like the Sol is under $10,000. And if you can add that to your intraoral scanner, you've got a digital workflow that can actually produce all of the things that I've just spoken about. And that is one really, really good reason to start 3D printing. The other reason why I think getting into 3D printing is great is because designing for 3D printing is changing dramatically. There used to be a time when there was a massive learning curve to learning CAD software. There used to be a cost to CAD software as well. Today, you can get free apps like Medits apps, and Medits apps will design let's say a splint using artificial intelligence in something like 5 minutes. I'm not saying that's necessarily the best way to go for every splint, but I am suggesting that things are going to get far easier. You certainly have free apps with no cost to design crowns, to design dentures, to design impression trays, splints, night guards, so many different applications. And you do have high-end CAD/CAM software as well. There's other restorative software that's free, like Clinox, for instance, or at least it's a paid subscription model that isn't dramatically expensive. You got Blender for Dental, excellent software that's compatible as well, and reasonably low cost for its modules, almost almost free in one way, in some ways. And then you've got, of course, the high-end CAD/CAM softwares that still charge you a price and a sub to use. And InLab and ExoCAD and 3Shape and some of these softwares are still very much in the market, and are still some. I think they'll continue to be around for certain types of design as well. But there's a lot you can do with free apps today, and it's never been easier. What matters in 3D printing then, if you're convinced that you do want to get into 3D printing, what is it that you should be looking for if you're going to get in? Well, again, this is from an LMT survey, and I've listed about 4 different criteria that came up from that assessment. And it seems to me that these 4 are really the key criteria to look for. Certainly, you want accuracy. You want things to fit, whether it's a splint fitting on a dentition, or a surgical guide that fits a bunch of implant drills, or a denture that fits mucosa, or a crown that fits a prep. Accuracy is important. You want speed. You certainly want efficiency in production. You can't be waiting 3 hours for a printer to put something out. And things are getting remarkably faster. You want reliability. You want consistency. You want that to happen day after day, case after case. And you want things to continue to stay economical. They're incredibly economical with printing. I mean, think about it. A surgical guide is under $10. A crown, for instance, is under $3 perhaps. Something like a denture is again under $10. So, you're looking at really, really low cost production compared to many other conventional costs of production in dentistry. The Sol ticks all the boxes for me, without a doubt. This is a printer that is certainly accurate, certainly fast, certainly reliable, and certainly the cost is very reasonable with its resins as well. Very beginner friendly printer, works right out of the box, doesn't need any calibration. I literally ran all of my sols, rigged them up, poured in my resin, ran my first print faultlessly without a problem. The sol uses LCD technology, and that's just a way of exposing the resin that you want to cure to light. The sol also uses LEDs, which I like, because you can distribute them better for light intensity, for curing what you're printing. They're also calibrated, and I find that with the kind of optical engine that the sol uses, this is a very effective way to produce 3D prints as well. Some of the other reasons I really, really like the sol is because it gives you a choice of 3 platforms. Now, what's a platform? A platform is essentially this black flat thing that in the picture is attached to the 3D print. You get 3 different sizes with the sol, and we'll talk in a moment about why. The sol is also made very well, very robust. It's completely made of metal, hardly any plastic in there, very strong, very well built, and I like that about the sol as well. The sol offers extensive connectivity options. You've got USB, you've got Wi-Fi, you've got Ethernet. It even offers you an offline mode that's recently come up that's convenient at some times. The sol also has excellent resin containers that we call vats, and these vats. I like how they're designed. They're made of die-cast aluminum, and they're really nicely designed. They have positioners that enable you to seat them faultlessly each time you take them back to the printer. And I also like the fact that when you seat them on a bench, you don't damage the film that underlies the bottom of the vat. These are advantages you'll come to realize when you actually use the sol. I want to say a word or two about the build platforms that the sol comes with. One of the things we realized very early with 3D printing is that the size of the build platform was directly proportional to the speed at which you could print. That's generally true, at least. And this is really based on fluid dynamics. And if you have a small build platform versus a large build platform, it's common sense to understand that every time the build platform sinks into the resin to print, a smaller platform displaces less resin. What that means is when the platform moves out of the resin, there's also less resin that needs to return to the displaced void, if you like, for lack of a better description, to take the resin level back to normal within the vat. So if you use a smaller build platform, you displace less, the resin returns faster. In effect, it could be quite surprising how much that reduces printing time. So really, we've realized that smaller build platforms produce faster prints, and sometimes, in some ways, even more accurate prints. And so Sol gives you a variety of platforms. And if you're printing something really small, like a crown, then, for instance, you could use the smallest build platform and things will print really fast. If, on the other hand, you're printing something that's kind of limited to one arch or is half an arch, like, for example, a surgical guide or a splint or something like that, then you can use a medium platform. On the other hand, if you're going to stack a bunch of models on the platform and you're doing orthodontic aligners, for instance, you could use a large build platform and get more models on the platform as well. So it really has fantastic application. I'm not aware of any other printer that actually provides varied size platforms, or at least I'm not aware of something like that. I'm not saying that doesn't exist, but as far as I know, I haven't encountered this offering from any other printer. So the small build platform pretty much is 60% faster compared to the large build platform, and the medium build platform is at least 50% faster than the large build platform. And you can see in the lower right corner there, that's the small build platform with 3 crowns on it. And so if you're printing something really small like that, you can get a really fast print. And so this is a very, very good advantage as well with the Sol. The Sol also uses software that I really like. Alpha 3D is seriously no guesswork software. It's very good software. And what the software really does is it generates the slices that helps the 3D printer understand what it needs to print in each instance. So you print a slice at a time, pretty much, and these slices are spaced apart by 50 microns, 75 microns, 100 microns, whatever. Now, 50 micron prints are generally higher resolution prints than a 100 micron print. That's not necessarily beneficial always, but in general, you would use something of a higher resolution for more accurate printing in general. So the software does all that slicing for you. The software also generates what are called supports, and supports are what the printer generates to connect the build platform to the print itself. You can print without supports, you can print direct to platform as well, and sometimes that's useful to do as well. But if you have supports, then prints are easy to take off the platform, and these supports pretty much peel off the model after that, leaving behind little knobs that you can grind away quite easily. Anything that's 3D printed needs to be washed in alcohol to get rid of excess resin. Now, this is an important process. You don't want to overdo it. You don't want to underdo it. And this all comes with an alcohol washer that has 2 tanks in it. And I love this because I've used single tank alcohol washing devices before, and typically when you take a print straight out of the printer and dump it in the alcohol washer, you'll find that the alcohol gets dirty pretty quickly. And if you only got 1 tank, then you're changing a lot of alcohol out at each time. Whereas if you have two tanks like this, then you can wash in the first one, and then after most of the resin has been gotten rid of, you can then transfer the print to the second tank. And that's great because you're changing only 50% of the alcohol, and so you consume much less alcohol. And this device is part of a calibrated, validated workflow as well. It's got a timing for different materials, and as long as you follow the manufacturer's recommendations for a given resin, you'll find that it works very, very well. Um, the Sol workflow is completed by the CURIE curing unit, and I will talk about this a little bit in a moment. But fundamentally, the CURIE is a unit that's designed for Class 2 biomaterials. Now, these are biomaterials that the FDA classifies as needing special controls, which means, I mean, it's one thing to just print, it's another thing to just wash the model. But if you don't cure in a really good and appropriate curing unit, then you haven't really produced a device that complies with requirements. The CURIE is an unusual curing unit, and we'll talk about it in a moment. I'll have to admit that I was skeptical about the CURIE when I first got it, because I was used to curing with a nitrogen supplied curing unit like this one. This is Auto Flash from a German company called NK Optic, and is a fantastic curing machine. One that I really, really like. It's supplied by nitrogen so that the nitrogen scavenges the oxygen. Similar principle to curing dental composite, really, a composite, as you say in the United States. But this machine works really, really well and has nitrogen and flashing LEDs that produce a really outstanding cure. That's a fully cured denture base, for instance, out of the Auto Flash. Now, with the CURIE, what I really like is the fact that you don't need nitrogen. This unit is a multi-wavelength curing unit, which means it will work pretty much with any 3D printing resin on the market. Again, that's something I don't see in curing machines. The most popular 3D printing curing machines that come with most other printers are single wavelength printers. They're typically 405 nanometers, and you get 3D printing resins that vary anywhere between 385 to 405. The CURIE will do anything between 365 to 405. It's got multi-wavelength LEDs in it, and that's absolutely fantastic. The LEDs are also distributed all around that curing chamber. On the lower left corner, you see what the curing chamber is like, and you got LEDs all around them and mirrors all around that chamber, so these lights are reflected as well. But what I really like about the CURIE is it has validated workflows for many different types of resins, and you can dial up the resin, the specific resin that you are going to be using. Ackuretta keeps adding to the resins that are compatible with its printers, and the firmware on the CURIE is something that's easily updated with a micro SD card as well. And so all of these make this a very nice future-proof curing unit that should work with a significant number of resins, because, as I said, Ackuretta keeps ramping up the number of resins that you can work with. Ackuretta does make its own resin line. The Curo series is an excellent resin line. I've used quite a few of the Curo resins. I've used Curo Model, I've used Curo Guide, I've used Curo Splint, and all of those are great resins, and very good resin line. What I really like, though, is that the Sol is compatible with a whole bunch of other resins that are not even made by Ackuretta. And these are some of the resins that initially got me very excited with the Sol. The Key Splint soft resin, the Big Ovasio Smile Crown Plus resin, those were some of my favorite resins. I've never used Key Cast myself, but I know several users who love Key Cast, especially lab dental technicians love Key Cast as a resin, and they love the fact that the Sol is compatible with that resin. Very important to cure castable resins properly, though, because if you don't cure them properly, they don't burn out properly, and they leave a residue on the model, and that, of course, then affects casting and ruins everything. If you're casting in gold, for instance, you're not going to like it very much if the model has residue left behind on it. But that comes right down to curing Key Cast properly, and the CURIE certainly does that. I did mention that Ackuretta is compatible with a whole bunch of materials. And some of my favorite companies are on this list. I love Bega, I love Pacdent, I love Keystone, I love Ceramco, and of course Ackuretta for its own resin. So there's I love Denka as well. There's a whole bunch of materials there that you can work with, and this list is continually growing. I really want to talk about what matters to me, though, that I want to add to that list I originally brought up, because I think that as 3D printing is increasing in terms of application, as more and more dentists and labs get into 3D printing, there is a lot of neglect of what I call validated workflows of validation. What's validation anyway? Well, these resins they have photo initiators in them, not very different from the dental composites that we use for restorations. And these photo initiators respond to a UV wavelength in the 3D printer and indeed in the curing unit as well. And of course, you need to make sure that you wash off excess resin each time you print something with these resins. Well, it's hugely important then that companies that make printers and companies that make curing units and companies that make alcohol washing units test the resins that they say these units will work with. And Ackuretta will typically work with a resin manufacturer, calibrate the resin parameters for every resin. We call that a profile. And eventually they generate a profile that's then taken further in terms of biocompatibility testing, mechanical property testing, and eventually when Ackuretta says this resin works and the resin company itself lists the Sol as one of the printers that is validated for use with their resin, it's, there's a lot of background work that goes on behind the scenes before one gets to that with any kind of resin. A couple of references there about literature. Most of the articles that I'm mentioning on this presentation, I've got full articles, and Ackuretta will be putting them out on the chat for everybody to download. These articles, many of them are out there in the public domain as full articles, so there's no copyright issue. And so I'm just sharing links really to where they're available. And so if you go through some of these articles, it's quite interesting to see why we do validation in the first place. This is one of the earliest studies that came around in 2021. It had to do with reproductive cells, mouse oocytes, in 3D printing plates that were cured for different durations of time. One particular plate was treated with oxygen plasma treatment. That was pretty much the only plate that allowed the oocytes to go to maturation, to actually cell divide through meiosis in vitro. All of the other plates actually failed in the study itself because of toxicity due to exposure to 3D printing resins. So there's just one example of how massively toxic some of these resins are. We know as well that some of these resins are carcinogenic. And if you think about the fact that you're going to be exposing people sometimes to medical devices for sustained durations of time, think about a 3D printed denture, for instance, and you know that that's vastly different from a 3D printed guide that's only going to stay in the patient's mouth for the duration of your surgery. But then we're printing splints, we're printing Nightguards, we're printing dentures, we're printing crowns. These things are going to stick around in a patient's mouth for sustained durations of time. And I think any conscientious clinician or healthcare professional wants to ensure patient safety. It's not all bad news, though, and I did put in some very positive studies. This one appeared in 2020 in JPD, no less. And this study looked at a bunch of resins that are all a bunch of polymers that we use in 3D printed resins, and all of these chemicals, all of these have demonstrated favorable biological and mechanical properties when they've been treated properly. So if you print them in a validated workflow, you wash them properly, you cure them properly, they retain accuracy for 3D printing applications. They pass cytotoxicity testing, and all of these are very useful materials. Then all of them go into so many other dental materials that we use on a day-to-day basis, but they also go into a lot of 3D printing resins. And so if you are using a validated workflow, they certainly have no problem whatsoever. Here's another study. This one used an artificial aging method with artificial saliva, and demonstrated that if you wash properly, you print properly, you post cure properly, microbiologically there is no cytotoxicity and cell viability is no problem at all. Physical properties and mechanical properties continue to be well retained as well. Again, good news. This is an interesting study because it showed us that if you don't process materials properly, it can affect the shade of something that has shade implications. So, for example, if you're 3D printing teeth, for instance, or you're 3D printing veneers or definitive restorations, for instance, and you're looking at getting accurate shades, well, it matters that you process those resins properly if you want them to retain shade properly as well. So there are lots of implications for a validated workflow. Patient safety is just one of them. But if you really want to get into 3D printing and if you really want to do it right, then it's hugely important that you look at a validated workflow. The Ackuretta workflow for the sol is validated at every stage for the resins that the unit says it's compatible with. The printing, the washing, the curing, and indeed the post-process where you polish the resin as well. All of that's been tested. And if you're working with the approved list of resins, then you should have a validated workflow. Validated workflows do begin with good intraoral scans, however, I will say that, because I do see situations where clinicians tell me about guides that don't fit or crowns that don't fit. And then I often ask the question, where was the data for the original print generated from? And then if you look at some of those intraoral scans, they tell you a different story, of course. If you're doing 3-segment scanning, which means you're picking up data in three different takes, if you like, you end up often with inaccurate scans. Data is clearly showing us that single-segment scans or dual-segment scans are definitely the most accurate. There is a strategy to scanning. You do need to learn how to scan properly. And as long as you're doing that right and you're giving your printer accurate data, there's no reason why a validated workflow will not produce an accurate outcome. And that's very important to understand. But think about that. Validated workflows do begin with good intraoral scans. So you want to get into 3D printing, but you find it daunting. And I encountered this with clinicians as well. But you really have many options in today's world. You can either learn to do everything yourself. If you're somebody like me, you're geeky, you're nerdy, you're a control freak, you need to know everything, well, you learn to do everything. And I love what I do. And I certainly know everything about every process in my validated workflow. But the other option is to train somebody else. And if that's, if it's not your thing, then you could train a staff member, you could train an associate, you could hire a technician. There's many options. You could train, you could delegate all of the workflows to somebody else. You could also outsource to design companies. There's Evident, there's I forget the name of the one that 3Shape has, but anyway, there are outsourced, there are dental designers that you can outsource workflows to. They could do all the designing for you from raw data, from intraoral scans, and they could produce the final file for you that you just need to print or mill and deliver to your patient. That works for some clinicians as well. I'm going to suggest, though, that your need for all of these things is going to become less and less because artificial intelligence is certainly taking over digital workflows. It's possible today to have, say, 3Shape Automate design a crown for you completely using AI. There are AI splints available with Medit apps, for instance. And so there is AI available for orthodontic aligners with a company called Neural Hive. And there's a whole bunch of applications that are going to slowly become something, to become something that artificial intelligence drives, requiring less and less human input. I mean, think about that. Absolutely amazing. I really think the time is as good as ever to get into 3D printing, therefore. And if it's something you're considering, think carefully about getting into it now. I mean, you're all familiar with the technology curve and early adoption and that kind of thing. The early adoption phase is long since gone. This is something that you really need to get into if you need to stay ahead of the curve as far as the profession itself goes. I want to thank each one of you for logging in and for being so kind to take time out of your schedule and your day to listen to this presentation. I do a multiple number of hands-on courses, do them all over the world. We've got one coming up in the United States as well. And if you are interested, please feel free to email me directly. Certainly have ones that have dates frozen in New Zealand and Australia if you want to make those ones. But thank you very much. And over to Tom now to take us through the question and answer session, if that's okay, Tom.
Sure. Actually, Dr. Surathu, thank you for a wealth of information outlined very, very with great logic. And I say things as, hey, if I can understand this, wow, I can only imagine what your dental colleagues on the other end of the line completely understand this. There were a couple good questions that came in, and we'd like to take more because we have a few minutes here still. And one of them, I answered a couple of these while you were speaking, but I'd like to hear your response. And when will printing catch up to milling in terms of speed?
I don't know the answer to that, Tom. I do know we're getting really fast with milling. Small platforms have made a huge difference to speed. And there's a couple of other nuances that have certainly contributed to speed of printing. And there are some significantly fast printers out there. The Sol is certainly very reasonable in terms of its speed. When will we catch up with milling? I don't know the answer to that. Zirconia milling is the only thing that's super fast milling. And of course, there's lithium disilicate, Emax, if you like. There are lithium disilicate printers out there, and there are zirconia printers out there that are already commercially available. But then, given how economical zirconia milling is, and given the fact that it's very accurate as well and very detailed, I don't really see an advantage for zirconia printing just yet. But we'll catch up. I have no doubt about that. 3D printing is far more economical, no doubt about that. Zirconia is the only exception.
Sure. So my response was, right, printing of a crown or a 3-unit bridge on a small build platform could be accomplished speed-wise within 20 minutes.
Yep.
And I think most milling machines out there are right around that same time for an Emax crown, let's say. And then, of course, we have, right, the post-processing. And on the milling side, we have the firing, right, in the oven, and the characterization and glazing and all of that. So pretty much a similar process after the product comes out of the printer or out of the milling machine. Do you agree?
Actually, PMMA milling takes longer than printing. PMMA is not
so
easy.
I'm giving them the benefit of the doubt.
Yeah, PMMA milling is not easy at all, and is a significant load on any milling machine. PMMA is a grabby material that takes a toll on any milling burr. And so when we're talking resin ceramic hybrids that we can print today, or pure resins that we can print in today, they even might be faster than a milling machine, really, if you're comparing apples to apples. So ceramics, zirconia, that's another story, of course. I think milling is going to stick around for a while, and we'll always have applications that milling is more effective for as a technology. But printing is certainly growing very quickly.
Sure. There was another question, and this is more of a sales question, I guess. And I wouldn't want to put you in that situation. Comparing the Ackuretta printer to one of our competitors, and really, and you touched on the benefits of the Ackuretta Soul printer, and that is the multiple build plates, 3 different size build plates that are interchangeable depending on what you want to produce, and how big your output is. The smaller the build plate, I think you spoke about, the faster the faster result, right? The faster printing time. And you had a couple other comments regarding the different size build plates within the system. Correct?
Yep, absolutely.
Yep. And then of course, you spoke about the resins that are available and how our system is open. And I think if we look at some of our competitors in the market, they do not have 160 plus resins available to them. And heck, and you highlighted multiple resins today from multiple manufacturers.
Mhm.
So I think that really separates us from some of our competitors.
And the potential for that list to keep growing.
Correct. Correct. Okay. Just seeing if there's anything else coming up in the chat. The CURIE is the best thing I got in my. So somebody commented the CURIE is the best thing I got in my third printing tools, in my 3D printing tools. Okay. Someone's happy with the CURIE. Just seeing if there's any more questions coming in. You can enter them in the questions, or you can enter them in chat, whichever you're more comfortable with.
There's a couple of questions that I see. One dentist has asked, he does a lot of vertiprep style crowns. How would a 3D printer come into this workflow? You'll be surprised how thin 3D printing can get with the right resin. If you know who Wally Wren is, Wally is actually shown that he's printing super thin prepless veneers with the right resin, with the sol. And so, with vertiprep style crowns, there would be no problem getting those crowns down to a knife edge with 3D printing. The same dentist has also said printing takes X amount of time, washing and curing takes X amount of time, and it's about an hour compared to 20 minutes for milling. Well, let's just compare apples to apples there. Firstly, the milling machine is a whole lot more expensive, and your return on investment is going to be particularly high, or at least your need for a good ROI is going to be particularly high. Not so with a printer, number one. Number two, milling machines are great with harder materials like porcelain. 20 minutes is what you could mill perhaps lithium disilicate in, or you can mill chalky zirconia in. Let's not forget that these materials then need to be sintered. These materials then need to be stained, glazed, all of that. So finally, if you add up the workflows, I think you'll find that they're pretty similar in terms of duration of time. And so, no, it doesn't take 45 minutes for washing and curing. Washing and curing is much faster than that, especially in the CURIE. If you're using approved resins, it's much faster than that. And so I think if you do the maths, you'll find out that it actually works out quite favorably in favor of printing, both in terms of time as well as in terms of return on investment.
Great. Thank you for the answer. And then just to follow up on that or add to it, if you join our Ackuretta user group on Facebook, you'll see that Dr. Renee just posted 10 beautiful veneers that he printed on the large build plate of the sole using Pacdent that Dr. Surathu had mentioned before, a resin that he will be using that he just received. So again, Ackuretta Facebook group, you can join that, and we'll have you come in, and you can see some of the different posts that other people have. But Dr. Renee just last week, or I believe earlier in this week or last week, posted one of his first prints, and it was a 10 beautiful veneers with Pacdent on the Ackuretta system. And then just to add to that last question, I think sometimes
I'll interrupt there, Tom, because you also need to understand that you can print 10 veneers at one go. Think about millions of veneers separately, block after block. So you really, printing has huge advantages when I do a full mouth rehab case and I'm delivering temporary crowns on 28 teeth. I've got them all done in the same amount of time as one crown. That's incredible. The washing is simultaneous, the curing is simultaneous, the printing is simultaneous. You can't beat that advantage with milling. Yeah.
Great point, right? Now we didn't even talk about that how many units you can print, it's all the same time, right? As long as they're all the same level on the build plate, that's how fast your time will go. So great point there. And then of course, I don't think, because this is more of an educational webinar, and people are asking the milling and the printing. I don't think everybody understands the cost of what a milling unit is and the cost of what an Ackuretta printing system is, right? And it's generally you could probably purchase 3 printers sometimes for the cost of what one milling machine goes. And then what we like to say in printing is, right, there's one moving part in our printer. And I think if you open up the hood of one of those milling machines, and I came from a CAD CAM company for many, many years, when you take the cover off that thing, it looks like this, it looks like a spaceship, right? And there's a lot of, let's just say there's a lot of liability or a lot of possibilities if something could go wrong. Not that milling is going away or printing is replacing it. I just think if you're questioning to add a printer, and I think you see the finances involved here, this is a very, very easy opportunity to get into 3D printing without a lot of money invested.
I think that's an important point, that milling's not going anywhere. Milling has its applications, printing does. I think if you're trying to substitute one for the other, you'll come up short at any time. But if you realize that they complement each other really well as technologies, then you get the best out of both worlds.
Yep. Okay. Any last questions before we sign off? I didn't see anything come in yet. Remember, if you're thinking about it, someone else is probably thinking about it. So
there
jump
is
into the chat.
Question about, is there a material hybrid resin that is strong enough for a knife edge margin? The patent rodent sculpture is supposed to be that material. I say supposed to be because I haven't personally used it yet. But I've certainly seen other dentists print some very thin crowns and veneers, literally see-through crowns and veneers. And let's not forget that these are part resin chemically, and so they're easy to bond if you follow the right protocol. And once you've got them bonded, that of course changes the physical properties that are placed in terms of a demand on the material itself. So yes, some of the ceramic filled resins like Bigo Vasio Smile Crown Plus and Crown Tech, as well as patent rodent sculpture, are certainly good resins for that.
Okay. And Dr. Surathu, did you share with us which intraoral scanner you use?
I've got two. I've got a 3-shape Trios, and I've also got the Prime Scan. The Prime Scan is easily my favorite scanner, and very accurate. I do edentulous scans for dentures with the Prime Scan. I do full arch scan body scans for full arch implant prosthetics with the Prime Scan. And I certainly do regular tooth preps and full arch crown preps and all that kind of thing. We've got super accurate scanners today on the market. The Prime Scan is certainly excellent, but so is the Trios 5. Excellent accuracy there too. I haven't seen any literature data out on the Trios 5 just yet, but there's some great data out on the Prime Scan from Adam from the International Digital Dental Academy out of the UK. Adam published an independent study using 9 scanners. I think it was year before last, and the Prime Scan came out winning over every other scanner that he tested. So yeah, we've got some great scanners on the market now. The Medic's also a very good scanner.
Okay, awesome, thank you. I don't believe there are any more questions coming in. So with that said, Julia, do you have a slide for us to show the Q4 sales collateral? There you go, thank you. And just so everybody can take a look and see, because we did speak about, comparing milling to printing and, what you can do with a mill and the time frame. And we didn't discuss really what your costs are. And as you can see, just under $9,000, it's your entire package. So it's everything that, Dr. Surathu was referencing before: the sole printer, the wash unit, the curing unit, the Alpha 3D software that you can go on our website, www.accuretta.com, and go to software tab and download the software. There's no charge to you to get that software. You could get it right now and walk through it. The more people that I have download that software, taking a look at it, they rave about the ease of use of our slicing software. So there you go, for $89.89. It's available in the United States through a select distributor channel. If you felt like you didn't want to part with $9,000, you could finance it for $389 a month for 24 months with no money down. The only thing is sales tax and freight are not included. Remember, we always have to give the government their fair share, or what they're looking for. So for $389 approximately for 24 months, you can get into printing and think about what you want to produce. If one night guard a month will make your payment on this, and after 24 months, it's all yours. It's not a lease. You're actually purchasing this. So great opportunities. Visit our website for our channel partners that are listed on our website, Ackuretta.com. Also visit Ackuretta.com for other information pertaining to the Ackuretta products, and download our software and see how easy the software is to use. Dr. Surathu, any last comments or
I'll just
things
say,
you'd like to?
I'll just say to everybody who's listening, just get into it. Yeah, just do it, as Nike says.
Yeah. There we go. I was about to say, we're not going to say just do it, but we'll say just do it with Ackuretta, and then I think we're clear. Dr. Surathu, thank you for your time. I know it's getting late in India now. We really appreciate having you on. We'd love to see you again. Very, very informative. So wish you the best. Enjoy your weekend, and everybody enjoy the weekend, and happy Friday to you.
Thank you. Thanks, Tom.
Bye-bye now.